Welcome everyone. Today we have our another new episode, and this is very important. This is our 474th episode. We will discuss about digital twin. I believe that Professor David Smith first bring these digital twins in World Talent Economy Forum this concept, but I'm sure that other speaker, Mr. Marshalls, Mr. Adams, and Mr. Frank can contribute a lot about the digital twin. I want to give chance first, Mr. Marshall, how you want to share your views about digital twin in manufacturing industry.
Well, thank you, Sharif. Just so people know what we're talking about, digital twin is generally considered a virtual representation that is done in real time with digital counterpart of a physical object. It's used in a lot of different industries. And my own father was involved back in the 60s and 70s. He was prolific inventor, had over 100 patents. And he became familiar with this concept early on. And unfortunately, he didn't live to see what we have today, which is very prolific. So I think that digital twin is used predominantly in manufacturing. At least that's where he encountered it and where he shared that information with me. My father was the inventor of the thermal barrier window. He also invented the Shelby brake system for the Ford Mustang, and he invented a lot of other products. And it's interesting. The concept was not digital then. It was more of the concept of being able to replicate things rapidly for prototyping in his day. They didn't have the computer technology or the bandwidth then to be able to do what we do today. Even in my day, a computer system the size of my cell phone, of my iPhone, had power of an entire building back in the late 70s in the university. So computing power has contributed greatly to the advancement of digital twin technology. It was advanced mostly and got a lot of its advancement, as far as I know, and I'm sure David can inform us even more so on the history of this, that it got its advancement out of NASA, the National Aeronautics Space Administration in the United States, for creating capabilities in outer space and building rockets and fuel systems. So my father, who invented the thermal barrier window, actually used a crude form of this. When he invented his thermal barrier window, he made multiple sets simultaneously of drawings that could, in case one got lost, that was one of the purposes of it. But it also allowed him to do side-by-side comparisons of any tweaks that he wanted to do to the technology, and he could do an instantaneous contrast comparison. Now, the one thing that he was able to do, because I didn't inherit that gene, but one thing he was able to do is he could simultaneously look at two sets of drawings and immediately, like a computer, grasp the difference in the details. That's essentially what electronic digital twin is capable of doing today. Then it wasn't digital, it was analog twin. That's what I would call it. But so basically, that's the concept of being able to duplicate designs and capabilities for manufacturing. That's how it started. It is now used, I can tell you, not just in manufacturing, it's also used in medicine. And it's also used, I know there's robotic surgeries that are done for heart surgeries. They're not, like you've heard of triple bypass surgery. Well, you can't use robotic surgery for that yet, but simple bypass surgery or putting stents in can use digital twin technology. And I know people in New York City at the New York Cornell Weill Medical Center that uses digital twin technology. So I'm just familiar with it through these areas of people that I've engendered. That's my intro part to it. I'll let David and everybody else bring more people up to speed on this.
Yes, thank you. Even especially, I want to give special thanks because you mentioned about your father. He's a great inventor, great scientist. As you know, that our content heavily used in academy. So if you share your father's profile, I want to share with our audience because our many students, youth communities, they can get some inspiration from your father's story. So it's really, really great for us because we should learn from different culture, from different people, and our people, our Asian people, has to know more about your father because he is contributing a lot for modern science, engineering, and technology. Thank you. You mentioned it. I really appreciate it. Professor David Smith, you first bring this digital twin concept in World Talent Economy Forum. So what's new you want to add for today?
I love Marshall's definition of it. I would only add one thing, though. It also, there's digital trends for process. As you look at that, that is where we're seeing a lot of very interesting innovation today. Um, I actually go back to the place where we saw a lot of physical twins, physical hybrid digital twins. If you go back to NASA and what happened on the Apollo mission to the moon, where the fuel cell blew up, and it was unknown on whether we could return the astronauts safely to the Earth. Digital twin like technology was used considerably there because they had models of the exact spacecraft in a lab in a hangar at NASA. And the NASA engineers spent actually thousands of hours collectively going through and running different scenarios. Would there be enough oxygen? What could they do to get enough oxygen? What could they do with power? And it was actually out of one of those twin scenarios that they figured out that the astronauts should come back in the lunar lander, use its resources, and then move back to the reentry vehicle. So that is a great example where the concept of digital twins was used very successfully quite a while ago. And the digital twin concept has so many different applications in business. And if you look at the companies like the IBMs, Microsoft, Amazon, if you look at the big accounting firms, particularly Deloitte, Accenture, and others, they all have programs in digital twins. The one at IBM is their digital twin for process mining, and it's used a lot in transformation. We've all heard the term digital transformation, and digital twins is used in there to create a virtual copy of the real world components in the manufacturing process or in the office complex. And the big thing about a digital twin is it uses inputs from real world components, and it's supposed to mirror the real world component status, functionality, interactions with other devices, and how it can be used. It's used as he said, in many different industries, and it's beginning to be used in consumer goods now, heavily used today in aerospace, and we're seeing digital twins begin to be even used in agriculture and in automobiles today. And this type of technology really is the future of manufacturing because of the growth of the Internet of Things and fourth generation IT, or what's called Industry 4.0, in their factories, and factories are becoming smart. And and it's very much you can take a model and run it. One of the other drivers of it becoming so popular in manufacturing is the increased use of robotics. And as robotics and automation is used more, the digital twin concept, where you can model and simulate it without actually having to destroy material, destroy raw goods like it used to be done, is a lot of advantages. I can tell you back when I first got involved with semiconductors, before I did the semiconductor industry roadmap, you would design a new chipset and then you'd go manufacture some of them. You would alter that design of the chipset, manufacture some more, alter it, and It was a very expensive and very time consuming process. Today, you can do that all in silicon and and design it, model it, in essence, manufacture it in a digital twin, look at the defects, look at the functionalities, the features, design it again in silicon, and do that again. So it's dramatically decreased the cost, increased the design throughput, and we're going to see that across all of manufacturing. Uh, so, Sharif, I hope that's a great add-on to Marshall.
Thank you. Uh, Mr. Adam, what you want to add for today's dialogue? We have some question from audience, but we will go for this question after this round.
Well, of course, digital simulations and virtual reality representations of real world objects are very useful, obviously, but perhaps in real life, the offline world, there are still probably at least one, two, or a couple of unforeseen circumstances that evade being taken into account in the virtual world. But I suppose as our lives become more and more integrated and ingrained with virtual reality as well as augmented reality, this view will just become increasingly chauvinistic and old fashioned, especially as definitions change and the answers to questions like what is real, what is not, what is a mere simulation also change, just as they have for the past several decades. One good example is social media. I greatly cherish many of the digital friendships and acquaintanceships that I have cultivated with people on different continents, on other sides of the world, where such a thing would be scoffed at by people who grew up way before any of this started to have any kind of impact on the way we live, relax, enjoy recreation, and cultivate friendships. And to me, these relationships are just as real to me as face-to-face relationships. A lot of them I may never meet, but still, this doesn't change. But at the beginning, I mentioned characteristics of the real world, nature, whatever, that are difficult to capture in simulations and may continue to be difficult for a while yet. And it feels like this could be the case with AI, artificial intelligence. How can we breathe life into our marvels of creation and know that it is conscious and self-aware instead of just aping a human, where it's programmed to, for example, imitate a warm-blooded raconteur or human charisma and creativity. Like my older brother worked at the Met Office and they needed supercomputers to model weather and climate patterns, but of course computers are getting smaller and faster, so who knows? Thank you, Sheree.
Thank you. Mr. Frank, thank you. After a long time, you joined with us. So, what you want to add for today's discussion?
Yes, sure. Well, first of all, there is with your permission, Mr. Sharif, there is a very question there from those attending through Facebook. It's about the value proposition of a digital twin in the manufacturing. I could only say, well, that you are able to trial and error processes that would be too costly to conduct or to emulate in the or the say real world. So that would be an answer for this person on Facebook. A very interesting question. To for my introitus per se, um, this is what I call an omnivergent technology. Not only it's omnivergent because it is the result and uh, the cause and the consequence at the same time of several other technologies. Some of them maybe IoT, 5G, and big data. There are more of these. So basically, they are we are seeing a convergence of these technologies in which we can our digital twins could be better and better, especially in manufacturing, where processes are very expensive to emulate or even so that it's going to simulate. That's one thing. In another, what I would maybe to discuss further is that what are we going to do with the now pervading, all invasive concept of the metaverse when it comes to exactly digital twins. How is this going to be used inside the metaverse, for example, or a metaverse, not the metaverse. How is that? How is this going to happen? This is going to be a fascinating discussion. Thank you.
Thank you, thank you, Mr. Marshalls. There are some question from audience. Like if you want to respond, let's say this question, Mr. Mahdi, how does the digital twin drive value for the manufacturing industry?
So it drives down costs for the most part. That's one of the main benefits of it. It has other benefits. So in the manufacturing process, what it does is it gives a checks and balance approach to manufacturing. A lot of things can happen in the manufacturing process. I remember when I was when I was about 16 years old, I worked in one of my father's window factories, fabrication factories, and also in his glass plants. And when you're manufacturing glass, it's a dangerous process, so you have to be very careful. A lot of manufacturing processes have inherent dangers in them. Obviously, today with robotics and artificial intelligence embedded in a lot of these systems, which a digital twin technology brings into play, it reduces the risk of danger to the process of manufacturing, as well as lowers the costs. I'm sure that David knows more than I do about this process than my limited experience, but because my experience is from when my dad was in its heyday, and it was not digital at the time. It was kind of like I said, analog twin, and I don't think they even thought about it that way. I know that a very famous professor out of Florida Institute of Technology, I believe, I can't remember the guy's name, was in the 1990s came up with the concept of digital twin, and then NASA actually created a roadmap for it that David talked about. That from that very famous event that occurred with the astronauts where their system blew up in outer space. So I can just say that and there's an example of reducing danger to people and also to surrounding environments where manufacturing plants are located. So I think one of the greatest benefits again is the reduction of threat of dangerous problems that can occur in manufacturing, and also and that's my firsthand experience of it, and then also the reduction in cost. I can only imagine today, and we should actually ask David this question, what the market size is on this, because I can only imagine that it must be growing exponentially. One thing that we've talked about in past sessions is artificial intelligence, and digital twin technology can be is a part of AI, and so or vice versa. I may have it confused, but I'm sure David can help me straighten that out. But I would say that there's an integration of methodologies and technologies that can lower costs and at the same time create a safer environment for where people are working in manufacturing. That's my take on it.
Thank you, thank you. Just one thing, like we have our website wteforum.org. If you have any write-up, example, even any scientific write-up, even if you want to write something about your father, you can publish anyone, Professor David Smith, Mr. Marshall, Mr. Adam, Mr. Frank, all of our speakers and audience, those who want to write something, example, anything scientific, they can write in our website and we're going to publish it. If you want to provide any kind of academic training and development, you can use our alnur.academy. And if you have a more scientific, like any kind of innovations or anything, we have another project, Asia Research and Development Institute, our website asiard.com. So you can publish your paper. So we are open, and side by side we are also publishing scientific journal through MDPI, as well as we are working with IEEE. So any kind of scientific things, because the youth community, those who engage with research and innovations, they need to publish a lot of papers. We are supporting many students, as well as we are providing scholarship as much as possible from our side for publishing the papers. Professor David Smith, I believe that you are one of the expert for this digital twin. And if you analyze these questions from Noor Fazrin, what is the prospect of digital twin in the manufacturing industry? And if you give some example in terms of North America as well as Asia Pacific.
Okay. I mean, that's a great question because there was a survey done last year by Deloitte in the manufacturing industry. And of the manufacturing executives they interviewed, 75% said they either have or will be implementing digital twin technology in their manufacturing process. So if I begin to look at it of what's its impact within this industry, it's pretty big because that's a very large percentage, well above what is an adoption curve. Marshall asked about the size, and some of the market reports I have seen says that in 2028, the digital twin market should reach $107 billion, and it's growing with a compound annual growth rate of about 54.7% between now and 2028. So steady market revenue growth, and really the market revenue growth can be attributed to its use in optimizing the manufacturing process, to optimize the process planning, to optimizing the products. Uh, and one of the things you see is we put more Internet of Things sensor data in manufacturing. It lets you analyze the key performance indicators very rapidly and model it and see if changes affect it and if it can address the inefficiencies that are there. Um, One of the places I saw digital twin technology used in a very, very advanced way is here in Austin. We have North America's F1 racetrack here. And if you want to talk about people using digital twins, where the stakes are very, very high and the winning margins are often less than a second, F1 technology is one of them. And you can see them. I have been in the pits, I've been in the drivers and the owners' areas and things. You can actually see in the owner's suite them running real time digital twin simulations, trying to eke out a little bit more speed, a little bit more performance out of the race cars in real time. So you want to do it in a digital twin because you don't want to cause an accident or cause something catastrophic there. So you begin to do it that way. Sharif, you also asked about some of the other applications, and there's tons of them. You know, in manufacturing, shop floor performance, self-driving car development. How do you customize design? How do you do predictive maintenance? Uh, Marshall mentioned healthcare. Again, how do I improve operational efficiency? How do I improve personalized care? Retail modeling a bunch of customer satisfaction, customer simulation. How will they respond? Supply chain is one of the big places we're seeing it today with the disruptions from COVID and the whole supply chain. How do you optimize that shipping logistics network? How do you do digital modeling simulation to do digital twins of what are my alternatives? Can I go and to new suppliers? Can I go to new product economically? How do I predict the performance of the type of packaging materials I'm going to use, particularly with the nuances that we see today? Um, and there's just so many different ones. You know, I talked about how digital twins, which was actually a physical twin, was used in Apollo 13 because that program was back in the 70s. Uh, the in 2002 is when the digital twins was actually introduced into NASA, and you see that automobile industry big time. Uh, you see it going there. I think one of the other places you're seeing it a whole lot today is in construction. I've mentioned before how uh, the Tesla factory being built here in Austin has actually been in production well ahead of its schedule because of the use of digital twin technology, the use of particularly augmented reality technology as they built and qualified everything in it. And so Tesla batteries and Tesla SUVs are already rolling off of this new factory. That the uh, construction start of it was barely over a year ago. If you compare it to their first ones, it's been completed in less than half the time. And I think a lot of that is through the use of digital twins and also through the use of augmented reality, because augmented reality and digital twins actually go hand in hand. Because I can build a digital twin, use an augmented reality headset and system, and begin to see it not just on a computer screen, but actually visualize it in use in the manufacturing floor. And if it's a process improvement, begin to see, well, if we move this robot and if we add this here, what's it going to look like on the floor? And you can begin to work it that way too. So a lot of there. And the question and the on how is it being implemented in today's competitive market? That's really part of it. Is how do I increase my KPIs? How do I get more optimization out of my processes? How do I get more optimization out of my manufacturing floor? Can I decrease the cost by doing things differently? Can I increase my throughput? Can I do defect reduction? And digital twins is very effective at helping you look at options to decrease defects. That is one of its big uses, for example, in manufacturing the semiconductor industry, because a a defect in a chip costs a lot of money. A defect in the manufacturing process of the chip, where you have to throw literally $1 billion worth of chips away, is costly and it makes it hard to be competitive today. So that is a lot of the places this is using, and you think it's almost science fiction that you can have a digital twin. And in manufacturing, it's been proven. The current cutting edge, though, is they are beginning to produce digital twins of human beings. And I would love to have a digital twin of me to see if this medicine's going to work or that medicine's going to work, or gee, if I take this supplement, will I lose weight? If I take this supplement, will I have more energy? I
Yes, yes, sure.
I would love to do that on a digital twin, as opposed to having to do that and go, gee, that one upsets my stomach and things. So it's this concept of digital twin is really taking off very broadly, and not just in manufacturing.
Thank you, Professor David Smith. Mr. Adam, what you want to add? Because Professor David Smith actually add many things based on the question. So, any of the question you can take and you can response.
Thank you, Sharif. When Mr. Marshall was talking about the advantages, I had some thoughts. One of the advantages is that our creative faculties over the virtual world are more powerful and versatile. We have an endless space to build things, test things. We probably have more available space and room in cyberspace than we do in this real world cosmos, which is quite a scary thought, actually. Imagine being stuck in cyberspace and not know it because it's infinite and thus inescapable, which then touches upon like the simulation argument and the ethics of cyberspace and virtual reality. But anyway, but even with something as mundane as documents and published works, we can build millions of libraries of Alexandria or digital equivalents of. We have billions more articles and documents and important paperwork stored for safekeeping in the digital world than we ever did in the offline world. And again, something rather mundane and down to earth, that is less of a fire hazard then, for instance. But then it's more hackable and less secure than an offline counterpart, arguably. But one of the most important things we must take into consideration as a human civilization, in my opinion, is posterity, the legacy of knowledge, and the passing down of that knowledge from generation to generation, storing the actions of great people throughout all of history for future descendants to learn from and enjoy, and artworks and works of great creativity and engineering as well. As human civilization goes on for longer and longer and longer, more and more on, the total number of creative works, feats of engineering, cutting edge thoughts and philosophies goes up theoretically, because of course so much of it is lost to fire, war, destruction, civilizational collapse. So this is the advantage of digital libraries and digital custodians and keepers of knowledge, for example. And it is easier to create copies and backups as well in cyberspace. Imagine needing to build two real-world hanging gardens of Babylon in case one is destroyed, and then they both get destroyed anyway, and the third one is only half built, half finished, and just gets abandoned. So a bit more of a romantic argument there, but that is something I consider to be crucially important here. Thank you, Sharif.
Thank you. Mr. Frank, uh, can you hear me? Yes, there is a question that what are the tools needed to develop digital twins?
Yes, it's breaking up in a lot there for a second. Yes, I can hear you.
Yes, there is a question from Alia. She wants to know what are the tools needed to develop digital twins.
Wow, that's a good one. Well, first of all, and the rest of the panel members would agree with me. First, you need a lot of money funding. This is very expensive, and you need very good programmers or coders. That's something you need. You need very good servers as well. Very potent, in which you are going to be storing and you're going to be processing to and from them. Uh, what is an excellent mainframe. Oh, and also you need the say the human will. And I'm going to say this because well, it is an own historical. I was there in San Bruno in California, Silicon Valley, back in 2017. There was a company called Meta Labs. No relationship with the actual Meta in which Facebook has morphed into. It was called Meta Labs. They were developing these mixed reality goggles, for example, and they said to me that they were doing all these medical research, but also they were talking about, well, how are we going to make, for example, better hand tools for example, for carpenters? How are we going to simulate that? They were working on these things, right? And they said to me that the challenge is basically within the manufacturing industry, which tends to be very conservative. So there is this it's not a fight, but it's a struggle per se. That you have to convince these traditionally minded fields and sectors to adopt technology to make the use case, a business case, and mass to mass roll it to roll it out massively, basically. So it is very expensive to do it, and not everyone is willing to do so, even if it becomes as for example Marshall explained very well. There is this need to improve processes, and basically there is a big risk management issue. Um, and basically that's what you require. But first, lots of money.
Thank you. Thank you. Yes, Mr. Marshall, you are a businessman. Mr. Frank
Yeah. So
actually brings the
yeah,
point like we need a lot of investment. So, what is the
right.
solution? Yeah.
So there are several solutions for the money side, but before we get to that, I do want to address one other thing that's related to what I'm involved in, which is sustainable management and addressing the climate crisis. A cousin to what we're doing in terms of industry development is what are called smart cities. These are cities that are being developed through urban planning. Urban planning's been around for millennia. I mean, the Roman Empire was built on urban planning, the road structures and all that. But what we have in smart cities are technologies that where the digital twin technology actually is very good for urban planning. Um, it's usually done in an interactive format, and the beauty of it is it's starting to be morphed into from the people I've been talking to, where they can take data flows from traffic cameras and things like that, and plan on a desktop or on a tabletop a virtual replication of a digital city right there. So Frank is totally correct. It requires investment, but it's not just the cost of money that's at stake here. And I think David can talk to this better than I can. It's actually a return on investment. It's an investment, and as you put money into these technologies, we should get a return. And what we pursue is the triple bottom line approach. In other words, people first, uh, planet next, which is the environment, and then profits follow. Um, and we think that I believe that digital twin technology is going to be one of those tools that we're going to see a great proliferation of, and that bonds like the climate bonds that are used to create taxonomies, as I've explained before, rules of the road, so that we don't greenwash or we don't tell people we're going to do one thing and do another. One of the things that digital twin technology can give you real time information to show that you're not greenwashing, that you are actually doing what you're saying you're doing in the physical environment and in the digital environment. And yes, it takes a lot of money to do that, as Frank pointed out. But I'm not familiar with the scope of funds that would be required. I'm probably going to work with David and the others to learn more about what kind of budgets would be required. We're already pursuing a climate bond, and we want to do more of that for the developing world. And I believe this technology could be useful in places like Malaysia, sub-Saharan Africa, where development is still going on. And as Frank pointed out, it cuts down the timing of being able to bring, let's say, a city to fruition or a manufacturing plant to fruition, and essentially at a lower cost than what it might cost you to use the technology. Yes, the technology could be expensive if you just look at it in and of itself, of all the components, the computer systems, the connectivity, and all that. But if you compare it to what it typically costs to build a city, smart planning and smart cities are beginning to use digital twin technology so that they can lower the return on investment. I mean, increase the return on investment and lower the cost. So that would be my take on it.
Thank you, Professor David Smith. What you want to add in terms of business perspective?
Well, one of the questions you asked were what were the tools needed to develop
Yes.
business twins, and a lot of it depends on the domains. Since the topic today is digital twins and manufacturing, I will say that one of the places you see a lot of the tools there is in the PLC systems that are used to drive factory automation, where you can use that as the input. And you're beginning to see more and more Internet of Things being used both as part of the PLC system and standalone through different parts of these. The sensor input, the manufacturing input is taken from there, brought back into usually a data lake or a data warehouse, and then from there beginning to use not only as part of the PLC system to actually control the manufacturing process, but then pulled over into the digital twin where you can run classic computer simulation models over it. You can develop your own. So you have three different extremes of the tools that you're having used. You have the sensors and the actual tools themselves, which are providing output in manufacturing. You bring them back to the systems that are controlling it, are the auxiliary systems and the ancillary systems there. And then you take those inputs and move them into a pure data modeling environment where you do the digital twin work. So I hope that's not too confusing to answer your question, but there's two. Now, if I go into other industries outside of manufacturing, the answer is different. If I am using a digital twin in retail, I might be collecting data from cameras and putting that into the system to see what my flow is through a retail facility. I might be interfacing into the financial systems to see how changes affect the money which is coming into the cash register. I might look at it in inventory turnover there. So again, a different type of front end to it of how I get the data that the digital twin utilizes. But the computer-based modeling tools can have very similar characteristics across them. But those are some of the tools for the different media. And I hope that helps answer that question for her.
Thank you, Mr. Adam.
Thank you. Yeah, David Smith raised a compelling thought about digital twins for real people, simulating what could or might happen if given a certain medication or put on a certain diet. Would the digital twin need to be so alike that it so mirrored that it risks being conscious itself? So then we get into philosophy of mind and suffering focused ethics here. Is it conscious and self aware because it needs to be an exact copy so that these simulations are most accurate with the most reliable results? We don't want to cause more needless suffering, and that is a consideration to take into account, even if it is unlikely to be as self aware. But whilst there is still a chance, then we need to think long and hard because, of course, unlikely doesn't mean impossible. It doesn't get us off the hook ethically and morally. So, yeah. Thanks.
Thank you, Mr. Frank. Can you hear me, Mr. Frank?
Yes, yes.
Yes.
And this is in regards to the final words.
Yes, basically, if you
Okay.
can, uh, if you want, you can give this answer: the prospect of digital twins in manufacturing industries.
Okay. All right. So basically, what is of concern to people. And by the way, for people who are watching this and that they say technically driven, I would point out to them if you have watched the social dilemma, for example, these Netflix documentary or docudrama, basically. There's a scene there that this diabolical artificial intelligence trinosophy is constructing and building a digital twin of one of the protagonists, basically. Well, that would be a very bad version of what a digital should be, basically. So if they that or watch it, so they concoct the idea in their mind what digital twin is. One of the concerns here for me in this case is that the digital twins stop being digital, meaning turning into basically, for example, software, okay, or basically just robots, okay, that they are going to do the work themselves. There are digital twins for robots as well. It's digital. They are exchanging information on how to improve processes. Yes, there is also a human processes, all 100% human processes being simulated and emulated in the digital world and how to improve them. But it is a concern for many people that these digital twins become robotic twins or the robotic, or early robotic or individual robotic element that is going to substitute many. It is already happening. That is going to substitute many human beings at their work, at the work level, or the rank and file level. All right, so this one of concern because this is being heard, this is being listened to and watched in Southeast Asia and East Asia as well, where things do work somehow different. They would say that for all the young engineers out there, the young technicians, to think about this and think in ways that you're not going to be taking away just per se. You're not going to be taking away somebody else's job. All right. So it is just a reflection for them.
Thank you. Thank you. This is really great discussion. I request all of our audience, please share our content as much as possible. I directly want to go for the concluding remarks. Before I want to declare that tomorrow we have our another debate. We will do debate on robot right. So we have a team. I think Professor David Smith, for tomorrow's session, he will be opposition leaders and with his team, and Professor Rob will be government this time. So hopefully this debate will be very interesting. So I want to invite all of our speakers. You can join in the debate team, and it will be very interesting. And I believe that our audience really like our debating activities. So thank you, everyone. I want to go for the concluding remarks. Mr. Marshall, what's your concluding remarks for today?
Thank you, Sharif. I actually, Frank just triggered in my mind a memory that, because I have pandemic amnesia, that's what I call it. I can't remember anything prior to the pandemic, and I can barely remember what's going on during the pandemic because I'm usually locked away in my home or my office, and I just go between the two, and I don't see anybody other than these Zoom sessions or these these digital actually training sessions. But he just triggered a memory in me. Prior to the pandemic in 2019, 2020, I was traveling quite a bit, and I flew a lot through Heathrow Airport. And he just triggered in my mind. I know that the United Kingdom, the UK, is a big proponent of digital twin technology, and it's actually created a organization that helps to create some rules of the road for that. I forgot what the organization is called. I tried looking it up, but I can't find it. But I do remember, this is the interesting thing. When I flew into Heathrow the last time, I flew into the brand new Terminal 1. It was brand new then. It's obviously not new now. But it was quite different than what I had experienced prior to that. And I fly into Heathrow a lot. And on my way to other locations in Europe and other parts of the world, the Middle East and et cetera, where we flew around. But Terminal 1, if I remember correctly, was actually began the process of design through a smart city approach using digital twin technology to simulate what the terminal would look like and how it would operate and the kind of flows that the air traffic would bring to that terminal. And if I remember correctly, at the time when I flew in there, it had already been operating at least 6 or 7 months. And I flew in and out several times during that period of time. And from what I understand, the digital twin technology was very representative of the actual simulations that they ran. And that so it's kind of a classic example of digital twin technology being used in the built environment. And as Adam mentioned, for medical purposes, and as both Frank and Adam have talked about, obviously, like any technology, it has its consequences for job creation and also its consequences for use. Any technology can be used for ill will. I mean, it can be used for military purposes to defend somebody. It can also be used for military purposes to attack somebody. And so we know that, like all technologies, and I agree with Frank and Adam and on their take on this, it's an ethical question and it needs to be addressed. I know that in working with David and Sharif and others in these debates, we always address the ethical questions. And our group, at least the people that you're seeing here today, are obviously proponents of positive ethics, and we want to engage people in a positive use of these technologies. And that's why I kind of remember that that triggered in my mind that the UK has a built group, a built technology or smart city group. Forgot the name of it, but it's out there to create rules of the road so that people can stay ethical and that the use of the technology is used accordingly. Obviously, everything depends on people hopefully abiding by the law. And I don't even know if there are laws that apply or applicable to the use of digital twin technology. But from what I can tell, I think this is an important issue. And I would hand that off to David and the rest of the folks for their final comments. Thank you so much.
Well, it looks like we've lost Sharif, so I will just go ahead and do the final comment here. Marshall, you're right. There's a lot of standards beginning to be put in place here. Some of them is the ISO group, the International Standards Organization, has been uh, developing multiple standards for digital twins in manufacturing, and particularly about how do you reduce data loss during the exchanges? How do you use a digital twin in collaboration so that gets actually some of the ethical issues? There's also places where you see other groups putting standards in place with them, particularly as it looks for exact dependencies in manufacturing. One of them, there's actually a digital twin consortia that is out there developing standards, particularly for interoperability in practice. Um, and there's many digital transformation, digital twin consulting groups out there where they are trying to push new standards that are going to be brought to base. One of the challenges with digital twins in the early days of digital twins is you were locked into vendors because you could not move it. But this improved integration, improved collaboration, improved new data standards uh, that are going to be used across this industry is making digital twins more transportable, more interoperable. And I think that's a good thing, particularly as you begin to look at solving some of the grand challenges. And a digital twin technology is very good at looking at hard problems and being able to run hundreds, if not thousands, of digital twin simulations and scenarios to address the hard problem set. Uh, Marshall queued it up. Uh, Digital twins goes well beyond manufacturing. And as such, there's a lot of opportunity for innovation still. There's a lot of opportunities to enhance it in academia. Adam brought up whether a digital twin can begin to do things on its own that is not programmed in by the sensors and other elements of it. And I think that's an area where there's a lot of academic research still going on, is whether you can have a self-evolving digital twin independent of the outside physical data which is coming in to inform it. And so there's a lot of academic applications there too. My take on digital twins is particularly in manufacturing. If you want to produce your product faster, if you want to optimize its process flow, which usually results in lower cost, if you want to optimize your logistics, if you want to optimize your design for manufacturability and your design for products you're manufacturing, digital twins is a great way to go. You know, the design for manufacturability is a science of the last 40 years, but the digital twin concept has advanced it quite a bit. So it's a technology that I think is good. Uh, I wish we could use more physical digital twins. Uh, for example, here in Austin with this little cold front with now about an inch of ice on the ground everywhere, I wish they had used digital twins to model some of the electrical distribution because we have widespread power outages today. This is going to get worse tomorrow. But even in places like that, I can see how a digital twin technology could be used as you're taking input from that infrastructure, running these simulations on the digital twin, and trying to decide how it should be used. Where do I shed load? Where do I see impending outages where a power line, because of the weight of the ice, might cause the power line to go down, which is a lot of what's happening here today and tomorrow. Um, so a lot of affability there, and it's a concept that I believe is going to pay back tremendously.
Thank you, Mr. Adam. What's your concluding remarks for today?
Thank you. One of one of the concepts in transhumanism and futurism is mind uploading for the purpose of extending lifespan. So if you're elderly and do not have long left to live in your original body, or you've got a terminal illness, and you upload your consciousness into a supercomputer to keep on living in a more robust substrate, is that still you, your original consciousness, or is it now two consciousnesses, two people, or just a simulation without the breath of life resulting in your death anyway? So again, with digital twins of real people, is that digital twin being an exact copy just virtually, does that create a second consciousness? Is it two separate consciousnesses? Is it still just one person with two consciousnesses instead of being two different people? What if the digital twin wants to live and doesn't appreciate being forced to experience experiments with diet supplements, or worse, like what David touched upon? So maybe we can never know, because but these are mind-blowing consequences potentially. So yeah. So,
Thank you, Mr. Frank. What's your concluding remarks for today?
Sure. Just want to add to Adam. The mask of words. Okay, so going back to the ethical issue of these technologies, basically, myself, I am a member of what is called here in Spain Odisea. That would be in English the Artificial Intelligence Observatory for Societal and Ethical Impact, and we work with several offices in government here in Spain and also in Brussels. That's the European Union in our case. Um, what we are trying to achieve is basically the another Marshall, by the way, a great man called Marshall, just like the one we have here, um, Marshall McLuhan in this case. He said to us more than 60 years ago, he said, we shape our tools and thereafter our tools shape us. Of course, these technologies are going to have a social impact in an individual social impact. And that is something that also your students watching and listening to this should be aware of that. Okay, that this is not only in technique talk and stuff. It is also ethical because we have come to the point in all of humanity. Actually, we have come to the point in which whatever we do in one side of the planet is going to have an effect on the other side of the planet. So that's how pervasive technological innovation has. In terms of digital twins, yes, go ahead to design, to invent and reinvent, and to better processes and business processes, of course. Thank you.
Thank you. Thank you everyone for joining today's session. So tomorrow we have our debate. It's very famous. Many people around the world they watch our debate. So I request everyone, Mr. Marshall, Professor David Smith, Mr. Adam, and Mr. Frank, you also can join in our debate as a debaters. So thank you everyone. I request all of our audience please share our contents and support World Talent Economy Forum initiative. Your support will be very helpful for us. And thank you, everyone. Thank you. Bye bye and take care.
bye.
Goodbye.
Bye.